What do you need to know for your physics test? Here it is. First of all, please remember your formula sheet. I don't want to print 30 extras. I just don't. It's a waste of paper. 2 or 3 extras, I'll damage your self-esteem, but I'll loan you one. But you're in grade 10. It's possible, especially when your teacher is so kind as to put things on colored paper so they stand out, it's possible not to lose them. Just saying. Okay? You might want to have your formula sheet right side up. Not that I'm talking to anyone in particular. There you go. Key ideas. You need to know the difference between a vector and a scalar. Is it what? Scalars have magnitude, you can fill in the blanks, only. All vectors have both magnitude and, what was the second thing a vector had to have? Direction. So absolutely on your test on the multiple choice section, there's going to be 1, 2, maybe 3 questions where I simply give you a list of things and I say which of these are vectors or which of these are scalars. So this part you're going to have to memorize, Allison, which ones are which. What's the difference between distance, displacement, and position? Hang on, let me pause again.
Grade 8, 9, and
What's the difference between distance, displacement, and position? All right. Since there's 3 things, if I'm clever, I would divide my page into 3 things. What's the symbol for distance? What letter? What's the symbol for displacement? What letter? Also, how do I keep them straight? This is not displacement, that's distance. How do I make it displacement? The vector. What's the symbol for position? It's your change in displacement, whatever, change in position. Probably a vector there. I'm not fussy on the symbols in that I will not take marks off if you use the wrong symbol, but Alex, you'll need to recognize the symbols in the multiple choice or on the provincial so that you know what the heck they're asking for. Okay? What is the difference? Distance is a scalar. And really, displacement is change in position. Displacement is so let me give you a question you might see on a test. We have room to write over here. If you have a track that looks like this, and here's the start and the finish line, okay? If the circumference, however you want to spell it, is 400 meters, a standard track. If you run 1 lap, what's your distance? What's your displacement if you end up back where you started from? 0. Okay? D equals 400. Displacement, 0. Okay? I'll give you another good example of the difference. If you go 5 meters this way, and then you go 5 meters this way, what distance have you walked? 10. What's your displacement? Whatever Pythagoras gave you is that distance there. In fact, in Physics 11, you'll find you use Pythagoras quite a bit. Or we had those motion questions where you walked forwards 5 steps and walked backwards 7 steps. You've walked 12 steps, that's your distance. Your displacement, 5 forward, 7 backward, -2, or 2 backwards. Okay? Position is your location. So, I should say, position is your location relative to a reference point. I can't tell you my position. Oh, my position is 17. Doesn't tell you anything. I can only give you my position relative to something. My position is 17 meters north of the school. My position is 17 kilometers east of Vancouver. Those all work. So what's the difference between distance, displacement, and position. Position needs it's a reference point relative to a reference point. It's a location. Distance is how far. Displacement is change in position. What's the difference between speed and velocity? Which one's a scalar? Which one's a vector? This is the only one that I'll say is easy. Which one is a scalar? Which one is a vector? Yeah. What's the symbol for speed? That. What's the symbol for velocity? That. Okay? You okay? Is that your back cracking? Nice. Here's a speed. What's the speed limit on the low heat here?
80.
Okay, Alex, you with me?
Yes, sir.
80 what?
Kilometers per hour.
That's one way. Usually meters per second is a preferred unit, but kilometers per hour is an acceptable. That's a speed. How could I make it a vector? 80 kilometers per hour west. There's the direction. Magnitude, 80. Direction, west. What else? How to read a position time graph. Position time. What does the slope tell you? Slope is velocity. So what does the direction of the slope tell you? A positive means you're traveling or east or up, or okay, what? A negative slope, and these are my abbreviations for positive and negative. If I don't write the VE, I think it's just a plus sign and a minus sign, and I'm missing an equation somewhere. So this is just me being a nerd. Means backwards, or south, or down, or left, or the stuff we've traditionally called in the opposite direction. How do you find velocity from position time graph? One word. Nope. This was the key idea.
Slope.
Yep. Now, how do you find slope? Slope is what over what? Rise over run. Okay? What does it mean when two lines cross? Now, this is a color, and it worked on mine. On yours, it's a smear. When two lines cross, like right here, what does that mean? It means in English, they're at the same position at the same time. I'm not going to write that down because I can say it shorter. But what it does mean, if you're on a position time graph and the two lines cross, it does mean clearly they're at the same time, same position. It means they caught up to each other. They caught up to each other. That's really what it means. So that might be a nice question if they ask, oh, when does Billy catch up to Susie? Where they cross and then drop down to see how many seconds or how many hours it took. Or where, read across to see what location. If a race is being depicted, how can you know who is ahead? How can you tell who comes in first? So you need to know how long the race is. If the end of the race is right here, who finished first? This person. They finished in, I know you guys can't see on your graph, 50 seconds. This person finished in 65 seconds. Although it looks like the person in blue even got a head start because they didn't start at 0. They got a, whatever that is, head start. So you can get all this information from a graph. I made sure all the graphs that you have on your test are black and white, and you'll be able to read them. I photocopied it already, and I made sure it's legible. Yeah?
If the finish line is on a 70-second line?
First of all, the finish line wouldn't be a time, it would be a position. So if the finish line was right here on 70, which is right there above the 50, in red would barely have won. Blue is just behind. If the finish line was at the 50, blue had enough of a head start that they got to it first. Okay? Here, again, yours isn't in color, but mine is. Which of these would indicate somebody traveling forwards? Line A, line B, line C, or line D? Yep. Sorry? Yep. Nope. Here's how I know. Ready? I'll put a number on here. I'll say this is 6 meters. I just made that up. Here's what you're saying. After 1 second, how far away are you? Read it to me. After 2 seconds, how far away are you still? After 3 seconds, how far away are you still? 6 meters. After 4 seconds, how far away are you still? The only way that you can stay the same distance away is if you're what? What is a horizontal line on a position time graph? Yep. So you guys can make a little note here. The fancy word for still is at rest. By the way, what's the slope of a horizontal line, Cam? And what is the slope tell you on a position time graph? Velocity, technically, but speed. So what's your speed of this horizontal line? What's another way to say 0? You are at rest. Okay, Rach, that putting it all together. Which of these then would indicate someone moving forwards? Or up, or right, or north? Brooke, I need to see what the question told me. I need more information. Look at line B and line D. Who's traveling faster? B. Who's got a bigger slope? B. It's the same question, same answer. I just phrased the question differently because the slope is the velocity. Line A, this would be traveling backwards. And again, to think of it, Rachel, you're starting far away and you're coming closer. Oh, that's like coming towards me. That's like traveling backwards. Okay? What is change in position? What's change in anything? Okay, well, the symbol is that, and that always means, Matt, say it carefully because I think you got the words a little bit mixed up. Always means. Now, you can figure that out from your formula sheet. Look, here's a change in, and it's final minus initial. So if you blank, it's there. But that's one that's handy just to have right here, Julia. Change in anything, final minus initial. How do I calculate displacement then? Now let's go look at the equations. Here's my change in position, my displacement. One way to calculate it is average velocity times time. And you'll notice, Allison, as usual, I'm not putting a delta in front of the t. It's always a change in. I just get so... I really wish they hadn't bothered putting deltas in front of the t. Time is just how much time, please? Okay? How do you calculate displacement? That's going to be your final position minus your initial... It's going to be your change in position. Okay. Next page over. What does it mean when displacement is a negative? Yep. Quickly, Bunny. What does it mean when displacement is a negative? Okay. Or, if it's free fall, down, or south, or left. I need to know more information, but yeah, my default, Matt, my first thought is, traveling backwards. Because that's the easiest for me to wrap my brain around. What units do we use for displacement or distance or position? What do we measure it in? What's the most common unit? Meters per second is wrong. Sorry. Kilometers per hour is also wrong. Stay with me here. What do I measure distance in? You're overcomplicating it. Meters. Or kilometers. It's not a per anything. As soon as you're doing, you guys were all talking about speeds and velocities. What is time interval? Okay, technically, it's... Oh, wait a minute. We have that on here too, don't we? Right here. Displacement, change in distance over average velocity. Change in distance over... Really, it's distance over velocity if you're not accelerating. What if you are accelerating? We got one over here too. We'll come to that for acceleration. What do we measure time in? What are the most common preferred units for time? Seconds, hours, minutes, but seconds is the physics unit we like the best. I added this, and you probably know this, just so that you have it at your fingertips, though, just in case. How many seconds are in 1 minute? How many seconds in 1 hour? I'll give you a hint. It's 60 minutes and 60 seconds, or 60 times 60. You were right, Sage. What was it? 3,600 seconds, 1 hour. Okay? So you've got to be able to go from one to the other. Now, I didn't do it very often. I prefer to give my kids proper units, but on the provincial, they are going to ask you to do a unit conversion. So on your test, I think I asked you to go... it's going to come up right down here. How do you calculate velocity, distance, and time in a given question? What's the... from your formula sheet, what's the velocity equation? From your formula sheet, what's the velocity equation? We can't use acceleration. We haven't got there yet. What's the velocity equation before we knew how to do acceleration? It's basically that, and they got stupid triangles and junk in them, and okay, whatever. It's meters, if they give me something in meters, divided by seconds, or kilometers, if they give me something in kilometers, divided by hours, or something like that. How do we find time? That's distance over velocity. And again, Andrea, I'm ditching all the it's hey, this one. How will I know when to use that? They'll say, how many seconds or how long will it take? And in the question, they'll give me a distance, and they'll say I'm at a constant velocity, no acceleration. And the distance formula? Yep. No, I won't take marks off. Traditionally, we use lowercase. Traditionally, you use capital letters if you know capital letters are used if you know the quantity is never changing. That's just me being a physics nerd, but for what it's worth. So I'll do it right, because I'm a nerd. Distance is VT. I know it's, where is it? Average velocity times delta T, but however many seconds, or however many hours, and how fast. Need to be able to convert from kilometers per hour to meters per second, from meters per second to kilometers per hour. So, as an example, Alex, my friend, if I said go from 60 kilometers per hour, how do I convert that to meters per second? If I go from 48 meters per second, how do I convert that to kilometers per hour? Does anybody remember the magic number that it had to... Okay, it has something to do with that. You're either going to divide by 3.6 or you're going to times by 3.6. Which one? Let's guess. Maybe you times. Let's see. Now, 60 kilometers per hour, where do we drive 60 kilometers per hour? Okay, city roads. You've all been on city roads. You've all been observant. So, if we multiply, what that's saying is, when you're on the city roads, you're going 216 meters, 2 football fields every second. That means when you're driving at 60 kilometers, if that's correct, when you're on, imagine yourself on the city roads, from here, you just crossed 2 of our fields. Is that how fast you go? So do you multiply? What do you do? Can you do that, please? Sam, you can go. Should have been, I'm sorry, Mr. Dueck, and I'll never do it again. Uh-huh. What is 60 divided by 3.6, please? Someone? Anyone? Sorry? I don't think it's 16 point, isn't it 16.6666? So wouldn't it be 16.7 if we round it off properly? It 16.7? All right, if you divide to go from kilometers per hour to meters per second, how do you go from meters per second to kilometers per hour? On your calculators, can you do that, please? 48 meters per second times 3.6. That's illegal on the freeway. That'll get you pulled over. 172.8 kilometers per hour. So on your test, Alex, put your phone away, please.
Sir, it's important.
It's really not.
It is.
Okay. On your test, I'm going to ask you either to go from kilometers per hour to meters per second or from meters per second to kilometers per hour. Now we got to chapter 9. Nearly done. You need to know the different scenarios of acceleration. First of all, you may recall, Ty, I told you, if you can imagine it, ask yourself, which way do I feel like I'm getting pushed? What direction is the acceleration? The opposite. Our bodies have built-in accelerometers, but they're always opposite. Okay? So, if you're moving in a positive direction, what would be an example of what's the simplest positive direction? Let's write underneath here, forwards, and you're slowing down. Oh, in a car hitting the brakes. What direction is the acceleration? Positive or negative? Can I go like this as my abbreviation for negative? Okay. What about if you're moving in the negative direction? What's the simplest negative direction? So in your car, you're in reverse. Yeah, next page over. You're in reverse, but you're slowing down. That's like you've been giving the gas in reverse. You're still traveling in reverse, but how would you be slowing down? You're hitting the brakes. Which way are you accelerating? Because you'd feel like you were getting pressed back when you hit the brakes if you were in reverse, if you're getting pressed back. Positive acceleration, forwards. This next one is the easiest one. If you're moving in the positive direction, forwards, and you're speeding up, which way is your acceleration? That's pressing the gas. If you're moving in the negative direction, backwards, and speeding up, pressing the gas, what direction is your acceleration? Yep. And you'll notice, Sage, no matter how complicated a question they throw at me, because you've done this all your life, I tend to relate it to sitting in a car. Really. Okay. How to interpret what kind of a graph? What is the slope of a velocity time graph? Tell us. First of all, slope of a position time graph told us velocity. Slope of a velocity time graph tells us what was the next big important idea. You absolutely need to know this for your test. So if nobody knows this, you guys better be doing some studying this weekend. The slope tells us the slope. I want more specific than that. I don't think it's velocity because position time told us velocity, so slope of velocity time graph wouldn't tell us velocity.
Acceleration.
Matt! What?
Acceleration.
So first thing, you better write this down if you didn't know this. Slope of velocity versus time equals acceleration. That's absolutely crucial. So what does a positive slope mean? What did you just tell me the slope was the same thing as? You just answered it, same word. So what does a positive slope mean? A positive, I got to be fussy, not moving forwards, accelerating forwards. You could be moving back, we just said you could be moving backwards and still have a positive acceleration. All it means is you have a positive acceleration, right? So, positive acceleration, negative acceleration. What if the slope is 0? What if it's a horizontal line? What kind of an acceleration would that be? And we have a fancy phrase, 2 words for an acceleration. Huh? That's for a speed of 0. Nope, you're moving, but you're not accelerating. What's the fancy word for that? 2 words. I heard it, you're right. Constant speed. What does it mean if the line is above the x-axis, like this one right here? What does it mean if the line is above the x-axis? What's right here, Allison? What letter? No, the main letter. V. What V stands for? What word begins with V in the physics unit, kiddo? Velocity. So this is a velocity versus time graph. Here's what it's saying. If you're above the x-axis, you have a positive velocity. So, above means positive velocity. You're going forwards. Below means negative velocity. Forwards. Backwards. Or you're going up, you're going down. If we were graphing my velocity when I jumped out of an airplane, I mentioned I jumped out of an airplane. If we were graphing my velocity when I jumped out of an airplane, would my velocity have been above the x-axis or below the x-axis? What direction is my velocity when I jumped out of an airplane? I mentioned I jumped out of an airplane? Negative. It would be something like this graph here, because I'd be speeding up, but in the negative direction. Okay? What does the slope of a position time graph tell you? We already answered this, but it's worth repeating. Slope of a velocity time graph tells you acceleration. Slope of a position time graph tells you folks, some of you need to do some serious studying because you're in trouble. What does the slope of a position time graph tell you? Velocity, not acceleration. You need to keep those two straight. I don't care. You're still writing the test too, Chief. Suck it up. Slope of a position time graph tells you velocity. How do you find it? Slope is what over what? Make sure you can do that okay. So, what does this graph tell you? What can you say from here? You're traveling forwards or up because it's above the x-axis? Are you speeding up, slowing down, or at a constant speed? Notice because now this is a velocity time graph. The height is the velocity. Your velocity is getting higher and higher. You are come here, Mr. Dueck. Positive acceleration, speeding up. What about here? Julia, here you're starting at a high positive speed. You're going forwards. Are you still going forwards here? You're above the x-axis. Are you still going forwards here? But are you going forwards as fast? This is slowing down, slowing down. It's traveling forward, slowing down. This is hitting the brakes would be a good example of that. Because after you hit the brakes, what's your final speed usually? What's your final velocity after you hit the brakes if you keep hitting the brakes? 0. You can see it's going to hit 0 right there. What about that there? Constant speed. I'll even say constant velocity. Hey, are you traveling forwards or backwards in that one there? How do you know? Which one is a constant speed going backwards? There is a graph. What letter? Graph A, B, C, D, E, F, G, or H. Which letter? Huh? So this one is constant velocity forwards, above the x-axis. This is constant velocity backwards. D is very tough. What's happening in D? Are you at a constant? Okay, this one here, you actually have a changing acceleration. We're not going to deal with that in Science 10. So if you want to, you can put a little line through that one. This graph here is a very good example of throwing a ball in the air. So here's the ball. When it leaves my hand, so use your imagination, it's just left my hand. What direction is it traveling when it's just left? Up, positive or negative, Matt? Is it at its maximum velocity, or is it slowing down, or is it speeding up when it leaves my hand? When it leaves my hand, you're saying it goes faster and faster and faster and faster? In other words, right there is where it leaves the hand. As it's in the air, what can you tell me? It starts to slow. How fast is it going at the top for a split second? Because that's how high we are, right there. That's the top. Then what? It starts to fall in which direction? Negative or positive? That's why this section is below the x-axis, negative. It's speeding up in the negative direction, and then there is where it hits my hand again. You guys with me? I've seen a lot of fidgeting, and got to cut it out. I'm doing you all a favor. What about this next graph here? Let's make this really big. How fast are you starting out here? 0. What direction are you traveling? Forwards or backwards? You know what? This is speeding up going backwards. This is putting your car in reverse and pressing the gas. Car in reverse, pressing gas. Or this is dropping an object. Because whenever you drop something, what's your initial velocity? 0. What's my initial velocity in that picture? 0. And then it speeds up as it falls down. Yep.
If that graph was longer, would it?
Like that?
Yeah.
What's your question?
Oh, no. I got it.
Now, eventually it's going to hit the ground.
Yeah.
We're not going to get that high tech. In physics 11 and 12, we can actually calculate what will happen when it hits the ground, but that's
That's what I was
later. Yeah, later. Okay? We already talked about this one, constant velocity backwards. What's going here? What's happening here? You start out traveling at a fairly constant velocity. What direction? Forwards. And then you travel backwards. Hey, you want to know what that is? I'll show you. Guys with me? I see lots of giggling and stuff, which means... What else? Oh, come on. Come back here. So, hint. Use your positives and negatives. Ask, is it positive? Guys, with me? Is it positive or negative velocity? Below or above the x-axis? So negative is below the x-axis. Positive is above the x-axis. Is it slowing down? Is it speeding up? Right? That's the slope. Okay? Use your signs to figure out whether it's a negative or positive acceleration. Or you can use rise over run. Bit more, we're done. How do you find acceleration from the equations if they give you the data and not the graph? What's the equation for acceleration? Doesn't quite say that. This time we have to be fussy. You going again? We're live. What was the acceleration? It doesn't say, I think, doesn't it say this? And in the next column over, it tells me that. Yes? Yeah, I never write the change in time, but you're right. It tells me that in the next column over. Let's put it together. This is really the equation, not on your formula sheet, but really it's V final minus V initial over time. I just put that right in for there. Okay? What was that? Okay. Velocity. Well, depends whether they want me to find VI or VF or that or that. How will I know which one? Well, usually initial and final are pretty easy to figure out because it's the starting or the ending. How fast are you going? What are other words for initial? Beginning, starting. What are other words for final? At the end, when you're done, afterwards. Okay? So we have VI equals VF minus delta V. VF minus AT. Mr. Dueck, it says VF minus change in velocity. Right there, baby. Right there. Mr. Dueck, why didn't you use this change in velocity? What's this question have right here? What's sitting in here? I can't use VI to find VI. That's how I know to use the one that doesn't have the VI. And this is why I would never teach it this way, but I'm stuck with it. No, not if you use this one. If they give you VF, the acceleration and the time, you can find VI. Or you can find VF by going VI plus A times T. Again, Mr. Dueck, that's not what it says. It says plus delta V. Yeah, but I'm not going to use this delta V because if I'm finding VF, this will be using VF to find VF. I don't want to do that. I'll use this one. And again, this is why I would never teach it this way. And what other ones have velocity in them? Change in velocity is V final minus V initial or A delta T. Depends what they give you. Last one. Time. Time equals change in velocity over A. Time equals change in velocity over A. Mr. Dueck, that's not what it said on the formula sheet. Really? Are you trying to get his attention or something like that? This is not the time to be doing something foolish like that, kiddo. Really and truly. Okay? Mr. Dueck, it doesn't say VF minus, it has a delta V there. Yeah, I'm using that one. That's the same as delta V. Mr. Dueck, why wouldn't you use that one? Because I wouldn't use time to find time. Wouldn't help. Last few things. So, determining initial velocity or final velocity from a formula. There it is up there. So they may give you acceleration, time, initial velocity. You know what? What you really want to do is remember to DFIC. List your data, find a formula, insert the numbers, and calculate. Always start by writing down what they want you to find. List your data. Check to make sure the units match. A couple more things. In free fall, which direction is positive? Yep. What direction is negative? Acceleration due to gravity on the Earth is what?
Neutral.
It's not, otherwise you'd be floating. The acceleration is negative 9.8 meters per second squared, and the units for acceleration are meters per second squared. Why negative, Taylor? What does negative mean in free fall? Yeah, down. Things fall, accelerate down. Okay? And we already said this, but it bears repeating. If an object is dropped or released, what's VI? 0. Okay? If you want to do some studying, these are good questions from your textbook. I will not be collecting them, but if you want some extra study, that'll work. I do have the answers. I'll put them online. What's my website? 2 more minutes before I turn you completely loose. Can you look at this handout here, please? This one called Acceleration. I handed this out a couple of days ago. If you don't have it, I'll get you a copy in a second. But make a note that you need a copy of this. Okay? Pause.